So that last unit, we talked about quadratic functions. It says here, algebraically determine the x-intercepts of this. So when you're doing that, you're finding x-intercepts occur when y equals 0. So you would substitute 0 in for y. Notice how that's in vertex form. So when we did that in vertex form, to find the x-intercepts, you undo the equation, opposite order of operations. So here we would add 8 to both sides. Divide by 2. Then square root both sides. So you're undoing, you're getting back to just x equals. Remember, when you do that, there's two possibilities, because when you square a positive, you get a positive, and when you square a negative, you get a positive. So this could be positive or negative 2. And then I like to show x on the left. Got to bring the 3 over, so add 3 here. So really it is 3 plus or minus 2. And so find those values. What's 3 plus 2 is 5. 3 minus 2 is 1. So there's 2 x-intercepts. Okay, it says verify your answers by substitution. So verifying, so x equals 5. Left side of my equation, right side. So here, actually, we'll just do it in coordinate form, right? So x-intercept of 5 is 5, 0. So we put 0 in for y. We got 2 times 5 minus 3 squared minus 8. Check out, make sure the right side equals 0. So that's 2 times 2 squared, which is 8 minus 8. So left side equals right side. And 1, 0. You know what that is? Okay, that's how you verify. Algebraically verify. Obviously, you can verify always on your own using your calculator, mentally doing it, but if you're asked to verify in a test, then you're showing your work. Keeping the left side separate from the right side. Okay? So, when we were given a quadratic function, to find the x-intercepts, we substituted 0 in for y. What this ends up being here is what we call a quadratic equation. This is the equation. It is an equation, but it's an equation of the quadratic function. This is just a quadratic equation. Okay? Then you'll learn about the quadratic formula in a couple of days, okay, but that's a formula. So, to summarize here, so to determine the x-intercepts of the quadratic function, we must substitute y equals 0, and then solve the corresponding quadratic equation. the solutions to an equation are called the, you can call them solutions, but they're also called the roots of an equation. Kind of think about a tree. A tree starts, it has its base is its roots, right? Put a seed in, or if you're starting right from the beginning, and it grows from there. So the roots is the beginning part. Okay, that's how the equation is built from certain x values. Therefore, the x-intercepts of the quadratic function are the same as the roots of the corresponding quadratic equation. Since these same values of x make the function equal to 0, they are also called the zeros of the quadratic function. So we've talked about that, right? Zeros and x-intercepts are for functions. Okay, they're the same. The corresponding solutions or roots to the equation that has y equals 0, so the corresponding equation, are all the same value. So x-intercept of a graph is the x-coordinate of a point where a graph intersects the x-axis. 0 of a function, value of x that makes the function equal to 0, these are the same, right? This just talks about graphically. Root of an equation is a solution to an equation. There's only one variable in it. You only have x's, or only have m's, or only have t's. Okay, and so then there's a summary there in the little boxes. So the x-intercepts of this function are the same as the zeros of this function, the same function. So they're the same. Those values are also the same as the roots, which you can also call solutions. I abbreviate it to SOL and S, to the corresponding equation. So notice how there's no y in that one. Okay, so since a quadratic function may have 2, 1, or no x-intercepts, a quadratic equation may have 0, 1, or 2 roots. So take a look here. These are the functions that are graphed. You can't graph an equation, right? Because there's only one variable. But the corresponding function you can graph. Then if you look at where y is 0, in this case, there are 2 x-intercepts on that graph, which means there's 2 zeros for that function. And then if we solve the corresponding equation 0 equals, we get 2 real roots. Real means real numbers, okay? Because with quadratics and any polynomial function, sometimes you might have imaginary roots. I'm not going to learn too much about that in this course, okay? But complex numbers, imaginary numbers, they're roots of negatives, square roots of negatives, okay? But we're dealing, all of these graphs that we're dealing with, real number system. So here, when it just touches, there's just one x-intercept, okay, of the graph. The function will just have 1, 0, and that means there's just one root. When you look at this, based on our multiplicities, remember that's going to be something like y equals x minus a squared. That was a. Okay? So there's only one factor that's different, right? So these are 2 equal factors. Sometimes when we're solving equations where we have something like this, we might actually say 1 real root or 2 equal real roots because of the fact that it's a multiplicity of 2. So either one of those, you might say. And then this one here, Obviously, there's no x-intercepts of that graph, so there's no zeros of the function, and the corresponding equation, there's no x's that would work. Okay, that's where you might have a root of a negative. Okay, so then, no, I don't know why that's showing up all the time. So to summarize what we're going to do, quadratic equation is an equation that can be expressed in that form. So that's the standard form where it's expanded out. And obviously a can't be 0. If a was 0, then it would be linear, which we already know how to solve. Okay. So how are we going to graph this? We can graph the corresponding function and find the x-intercepts. Okay. We can factor the equation. Okay, and solve for those factors, the 0 property. So that's what we're going to practice today. We can complete the square, okay, and then solve using the square root principle. So we know how to complete the square on this. That basically means put it into vertex form, back from functions, and then undo it like we did in that first example. So here, if it's in standard form, we learned in the last unit how to put it in this form, and then we can undo that to get our solutions. That's kind of the longest method. It's the one you're probably going to use the least. We might ask you to do one like that, but most times you always check for factoring, okay? Because that's the fastest. If you can't factor, then most times you're not going to do this method. You'll use the quadratic formula. So that's what we're going to learn in a couple of days. Okay? And then graphically, you can use to check. We might give you one question where you're asked to solve graphically, but really your calculator does it all for you. So we want to know that you can do it algebraically. Okay, so that's what we're going to do. So flip over. We've already done factoring.